Okay, um, one type of equation that comes up often in our studies is one that looks like this, for example. Okay, now what we're going to do is we're going to use what's called the square root property. Okay, and that works like this. You take the square root of both sides, like so. Now, normally this would be a principal square root, but what happens is that if we come into this, approach this problem as if we don't know what x is, then we saw that this thing here back in the past had to be treated this way. And this was a principal square root. Okay, so we took the principal square root of both sides. This is a 4. This, we recall from our work with absolute value equations, actually gives you two solutions, a -4 and a +4. So the author is just kind of eliminating this middle step here and just saying, you know what, let's do the problem like this. Take the square root of this side and just put on that plus or minus as soon as you use that square root symbol. Put it on one side. It doesn't matter which, but we'll keep it on this side. It's easier. If we have a choice, we'll put it on the constant side. So this gives you that plus or minus 4, and you just leave this side as an x. Okay, so we have two solutions either way. Okay, same two solutions. So that's what you can do. So for example, let's solve x squared equals 35. Well, x will be, using our principle, plus or minus the square root of 35. Okay, so we can sometimes solve problems like this one. Let's say 2x squared equals, let's make it 20, let's make it 24. Okay, that's 2x squared. So if I'm solving this, I would want to get that x squared isolated. So I would divide, this is a 24 by 2, so I'd have a 12. Then x would be plus or minus the square root of 12, which we could actually simplify a little bit more and write 2 root 3. That's what we learned in the last chapter, how to reduce those radicals, simplify them. All right, so that's how we handle those. Okay, so here we are with another one, another example. Solve this equation. Now it resembles the other one in the sense that we have the variable over here, variable expression, and we have it squared, and it's equal to a constant over here. So if we have that, now even if this is just an x, it's fine, but sometimes it's more than x, like this one. We have it isolated. It's isolated, so we're ready to just take the square root. So we'll go ahead and take the square root of this left side, and we'll put on that plus or minus on that side, square root. So this side we'll just leave as an x plus 2. This side we'll write as, well, we can write plus or minus 3 root 2. Okay, you can see how that comes at 9 times 2, and 3 comes out. Now we're not done because this is x plus 2, so we'll take away a 2. And then we remember that we can't just add radicals that aren't matching. This is it's a -2 plus or minus 3 root 2. And that's the best we can do. It's a little sloppy there, but let me fix that. Let me fix that. There's no reason to be that. sloppy. Okay, so that is plus or minus. Whoops. Okay, lost my place there. That is plus or minus that 3 root 2, like that. And that's the best we can do. We can't write it any simpler than that. Okay, now remember, that means that's two different numbers. That's negative 2 minus 3 root 2 and negative 2 plus 3 root 2. Okay, it's just easier to write them with that plus or minus in there. That's acceptable. Okay, let's try another one of these. Let's see, I don't want to do too many. I don't want this to be too long. Let's solve. X minus 1 squared equals negative 4. Okay. Now, that means is that we're ready to go. We've got the same situation that we had up here. We have the variable expression squared equal to a constant. That's what we have here. Okay, same thing, same form. So let's just jump right in and take that square root. And then we get the plus or minus square root of negative 4 under here. So this is a 3x minus 1. This side, however, we recognize as plus or minus 2i because of that negative, remember. All right, so the rest of it's just like the other one. We'll add a 1, add a 1. I'm going to take it over here. Well, you know what? Why don't I just scroll down a little bit if I can. Okay, there we go. So I'll add a 1. That means I have a 3x equals 1 plus or minus 2i. Okay, it's a complex number. You got to leave the 1 by itself. Now I got to divide by 3. So that's going to give me 1/3 plus or minus 2/3 I. And that's my answer. So sometimes you'll see it written like this. Sometimes they might separate it. They might write it this way. And they might write 3 plus 2/3 I. Okay? Okay, we're going to try this now. Okay, here's another example. We're going to solve this. And what's going to make this work is the fact that this side over here is expression is squared. It's equal to a constant. And if I jump in, I can immediately free that variable so that this will turn into, it's kind of slanted there, a linear equation. That's the idea. We get this down to a linear equation, which is easily solvable by isolating. Then I would minus a 1. So I'd have a 3x equals negative 1 plus or minus root 5. And then I would divide by 3. So I would get this. And I have my two answers. Now, so that's a little rehash of what we did using that square root property. Now, look at this problem. We can't do that. Okay, there's a couple reasons why it won't work. The main reason is that this left side over here, if I just, right now, I just take the square root of that, it will not become rational like this one did over here. This became rational because we had a perfect square. This will not become rational. It's not a perfect square. X squared is perfect, but this quantity, this whole quantity is not a perfect square. Okay? It's not a perfect square. What we need to do is make it into one, if we can. So at this point, you'd be asking, all right, what do I do here? I mean, this isn't going to work for me. So here's how we do it. We take that original, just leave this over here like so. You make a perfect square by cutting this in half. Okay, so I'll do that over here on the margin. I take that 6 and I cut it in half, which is a 3. And then I square the 3. I add it to both sides of this equation. So in other words, I add 3 squared, and I'll add it over here, 3 squared, to keep the equation balanced. But the beauty of this is that now this is an x plus 3 quantity squared. And this is just whatever it is, 15 plus 9, which happens to be a 24. So the point is now I've converted my left side into a perfect square trinomial by adding that 3 squared. I create a perfect square trinomial, which is then factored this way. It's a perfect square, so I can write it this way. And then in my next step, I'm ready to take that square root of both sides. So that's the idea. We turned it into a perfect square. That way we could do our square root property on it. So now we have this, and this one reduces to what? What's that going to be? 8, 3, 4, and 6, right? So plus or minus 2 root 6. And then finally you get this negative 3 plus or minus 2 root 6. That's our answer. 2 answers, by the way. So this technique has a name. It's called completing the square. Now, it has its usefulness in other parts of mathematics. If you continue on, you'll see those. You're going to see that it's a nice technique, algebraic technique that's used, like I said, in other places. But we're going to kind of render it obsolete in the next couple sections. You'll see, but it still has its value. Okay, more than just for solving an equation. There are other things we can do with it. So even in this course, you'll see a couple sections into this chapter what we do. Okay, so let's add a page here. Let's come down and let's get rid of that. Okay, now let's take an example. Just sort of random example here. And let's see what we get here. Okay, so let me get some lines in here. Okay, so here's an example. Let's solve. Okay, now we always try to solve in the easiest, most efficient way. But if we're told, like in this one, how to solve it, then we should use that method. So this will be solved by completing the square. Okay, so first thing is, this is not a perfect square the right way that it sits here. So first thing is we will remove that minus 2, that 2 by subtracting it. So it comes over on this side as a negative 2. Okay, now best approach here to avoid fractions right away, what we can do is this. We'll say that's a 5x squared, where this is minus 2x. Okay, and I'm going to leave a little space in there. Okay. Now, the reason I did this is because I really didn't want to bring fractions in right away into this method, so I got the 5 out here. Now, we'll keep track of this 5. What's half of 2? It's 1. Then you square it and add it. There it is. Square it and add it. Now, here's the problem. You're not adding a 1 squared. You're adding, because this is outside here, you're actually adding 5 times 1 squared. And that's what makes it equal. Okay. You're adding the same thing to both sides. So because we factored in 5, we got a little more bookkeeping to take care of here. We have to make sure. But now we have this. And over here, we've got what? -2 plus 5. So I have x minus 1 squared equals, 5 of that equals 3. Now, I want to take the square root here. I got a 5 here. The constants don't bother me, but I don't really want to have that under the radical. So I'll divide it out. I mean, we can't avoid fractions. If they show up in the problem, they will inevitably show up. You can't always avoid them. So, but now I've got my perfect square on the left and a number on the right. So I'm ready for the square root property, which I then apply. This is 3/5 into the radical. This side is just x minus 1. And this is just the plus or minus 3/5. I really can't do anything with that. I could rationalize it, put that 5 up like that. Remember how to rationalize, right? So that's x equals 1 plus or minus, I'm going to write this as root 15 over the 5. So that's it. Those are my answers. I got 2 of them there. Sometimes people might write this as 5 plus or minus root 15 over 5 like that. So that's the same thing. Now there's, you can't make a note that you cannot divide that 5 into the root 15. It's under the radical, so you can't just bring it in. If that 5 came under the radical, it would come in as a 25. And 15 over 25 would not help us. Just make it worse. Okay, so that's completing the square. And I think that should do it for now. You guys can work on those. The key with this one was watching that 5, keeping track of that 5 when we pulled it out. Okay, so